Hi, it's Jan Beta, and I'm going to build one of these today, or at least an equivalent, which is around a tenth of the size of this original thing. Which is, of course, a Commodore 64, in case you didn't recognize it for some reason. Everybody knows these, right? The story behind this video is that I built a little retro gaming corner in my living room over the Christmas break, basically. And it's still work in progress very much, but I have a Super Nintendo set up there, I have a Mega Drive set up there, I have my PlayStation 2 set up there, basically the consoles that I love the most of all of them. And I also want a Commodore 64 in there. But I can't fit a real one in there because the space is super limited. It's just a very small, tiny corner with the CRT that I'm going to show you later in the video if everything goes according to plan. Yeah, I don't have room for a real C64. I had one set up there, but it was a bit of a pain in the butt because I couldn't reach the keyboard and had to put it sideways to have all the connectors in and things like that. Just didn't work out physically. So I remembered a project that Randy Rossi had going around 5 or 6 years ago, the bare metal Commodore 64, BMC64, that is a bare metal version of the Vice emulator running on a Raspberry Pi. Works with the Raspberry Pi 2 and 3. This is a 3B+, so it should be enough for that. In case you don't remember the project, it's really neat because it focuses on the lack of lag, basically. So it has the least amount of input and output lag imaginable on an emulator. And I remember playing around with it on a Pi back then when it came out and was really impressed by it. It was way better than the C64 Mini that I have and probably the C64 Maxi because it runs the same software. The lag on those is, even for a non-gamer like me, I could tell the difference between playing on the emulator and on a real C64. And this thing, the software BMC64, has so little lag that I don't perceive the lag as is. It feels like playing on a real machine. So that's my solution. The other thing that I really wanted, which none of the other options offer, is Composite Out, which the Pi has a little audio output here, which also doubles as a composite output if you wire it up correctly and set some flags in the software. So this is going to have HDMI output, really crisp, modern output to hook it up to a modern screen, and Composite Out, which is going to be useful for my very retro setup using an old television as the screen. Yeah, I hope this is going to work out. As I said, I did this before, but didn't hook it up to a composite monitor, so we're going to see how it goes. The other thing that causes lag is the input, of course, and that is because most of the modern equivalents and emulators use USB as the input, and you can hook up gamepads and things like that, but USB is not quite as fast as the original machines, which basically ran wires directly to the I/O chips and had those communicate in real time with the processor and the code that was running on the computer. So there was basically no input lag, just the lag caused by the wiring, and that's very little. So that's another thing that adds to the lag on emulators if you run them on a computer. Usually this BMC64 offers to hook up a real C64 keyboard as well as 2 real C64 joysticks to the GPIO header here and have them communicate directly with the software. So pretty much the same thing that the old real computers did, but in software. So there is the emulation layer, of course, on top of that, but it's very fast. So yeah, It seemed to me like this is the perfect option for my space-saving problem. I'm going to walk you through the installation because I think BMC64 is a really, really nice project, and I'm going to talk about what this emulator can do a bit more while installing it. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do 3D printing, CNC machining, sheet metal fabrication, injection molding. They can populate your boards for you. They have a new service that assists you in designing your boards in the first place. Their services are excellent. The quality of the products is superb, and their pricing is super reasonable, so I highly recommend checking out the link in the video description in case you're interested. Back to our BMC64. So yeah, we don't need a lot for this build. I need a D9 socket for the joystick. I need an SD card. I think this is 4 GB, which is more than enough. I think the installation is just a couple of megabytes. It's not very huge because this is bare metal software, no operating system except for the Commodore 64 stuff on here, which is very small, of course, by today's standards. Power supply, we are going to need some wires to hook this up to the GPIO pins. We are going to need an adapter cable to have composite out from our audio jack here, but that shouldn't be a problem. I have a couple of those adapters, I think, which should fit the bill. Let's get into the software installation, which is the main part, basically. And then, yeah, we're going to figure out things as we go. One other amazing thing about this emulator, the BMC64, is that you actually have multiple machines emulated, all the ones that the Vice emulator can do. So the Commodore 128, the VIC-20, the Plus4, and the PET are also included in this emulator, and you can just switch machines through a little menu. I'm going to hook up a regular USB keyboard to my particular thing. I have a wireless USB keyboard which should do the job because I don't have room for a real C64 keyboard. But you can also hook up a real keyboard, and there's even PCBs to fit the Raspberry Pi with BMC64 running, and all the connections facing out in a real C64 case or one of the replacement cases that are available nowadays. So in some ways this is even better than the new C64 Ultimate, I guess, especially since you have multiple machines here. I think the C64 Ultimate has more connectivity. It of course has the real C64 cartridge port and things like that. This only runs off emulated images, disk images, cartridge images, tape images, just like your Vice emulator does. But I think that's pretty cool as well. So you can stick a USB stick in here and run images from there, and you can also put images on your SD card if you want. Budget Commodore 64 Ultimate, if you will. Going to go with the image. This is BMC64 4.2. So I'm just going to download that, and we are going to need some additional files for our emulator to run, because this doesn't include the Commodore ROMs. These are available from different sites. You need the kernel ROM, the character ROM, the basic ROM, and a ROM for the disk drive 1541. As you would with Vice. Some versions of Vice include these, but the copyright situation is probably even less clear these days than it was when this was released. So yeah, I'm just going to download the ROMs here from the link provided on Randy's website. And we need a basic ROM, first and only revision. And we need a kernel, the regular Revision 3 ROM is the latest one, the one with the least bugs. There were some minor bugs in the initial versions, I believe. And then we need some disk drive firmware. That's here. That's 1541, and we need the 1541-2 ROM from 1987. That's the one you want. Yeah, and we have to rename these later and put them into the file system. We also need the character ROM. Didn't see that. I forgot to download the character ROM. There we are, the character generator ROM. Okay, so that should be all the stuff we need to run the C64. And yeah, there are of course links for the other systems as well. I'm not going to install these yet, I think. Just want to do the basic installation of the Commodore 64 stuff because that's what I wanted. So we're going to use Berliner Etcher because it's just available for all the operating systems. You can use the dd command from Linux, of course, and from macOS, I believe, as well. But for the sake of making this as easy as possible for you, in case you want to do the same, I'm just going to use this, which is available for all all major operating systems at least. I don't think there's a BSD version for it, but if you're on BSD, you probably know how to use the command line. So we're going to go to our downloads folder and select our BMC64 image. And we're going to select the target, which is our MMCBLK0, which is our SD card. Select and flash. And we need to authenticate. This looks the same on all the operating systems I've seen it on, so should be very much the same thing. And then we should have our file system and everything set up correctly already. And we can rename our files that we need to rename, our ROM files, and put them on there. Yay! Flash complete. So we should now have our SD card. Yeah, with all the necessary stuff. We have folders for our emulators. And we need the folder for the C64, of course. So we need these files: kernel, chargen, basic, D1541, and these files that we, I think, already have. Yeah. So let's put our ROM files there. We have them in downloads and rename them accordingly at first. So this needs to be chargen without the bin. This needs to be D1541. 2. I think it's case sensitive, so we need to copy this exactly, basically. Kernel, the basic. So and these go into my C64 folder on the SD card. Yep, there we go. This should be all the code we need to run a basic C64 emulator. So let's try that. Yeah, I put the SD card into the Pi, hooked up this monitor here, and if everything went according to plan, we should already be able to start up our C64 by powering the Pi. It should take approximately 4 seconds to boot up, just like an older normal C64. Let's see. There we are. That's our C64 with a little scanline emulation and things like that. And I don't have any keyboard connected yet, but that's how fast this is. And another good thing about this emulator is that you can just cut the power and it doesn't affect the SD card. So you don't need any shutdown procedure or anything like that. You can just power it down like a regular C64. That's how easy that is. I'm going to have to hook up a keyboard, of course, to really use this thing. It doesn't really work that well on this screen, but it has a menu that you can access by pushing F12, and you can access most functions that the basic Vice installation has. have multiple drives, of course, and you can change the ROMs, and you can use cartridge images and things like that. You can have different keyboard mappings, basically. And the joy ports. You can swap the joystick ports, so one joystick connector, one physical connector should be enough for my uses. And you can also use USB gamepads and key sets. We can do a hard reset. That works just as it would on a real C64. Yeah, this doesn't look perfect. As I said, it's probably meant for a full HD screen. This is not a full HD screen, so the scaling is a bit off, but you can configure the output, the video output, in the configuration files, which is also relatively easy, I think. I want this on a CRT, of course, so we need Composite Out, and I'm going to see if I can get that to work. Not sure if it works right out of the box, but we're going to try. Now, getting Composite Out from this should just be a matter of setting it up here in the Machine submenu under Switch, and you can choose the machines you have installed, obviously, and there's some presets here that you can also change a text file to adjust them. But usually you would just go and select the NTSC Composite or PAL Composite, which is the mode I'm currently running in. And then you do a reboot, and you should have a composite monitor, in this case a PAL signal, on the Composite Out through the little audio jack on the Raspberry Pi. Or so I thought. The problem I encountered while trying that on several CRTs and my upscaler, and none of them output a proper composite picture. I got some flickery thing that kind of resembled the Commodore 64 startup screen. I used this adapter cable here, and that's the whole thing that is wrong in this case, I think. I think I would have gotten a perfect picture if this cable was the correct pinout. So these TRRS plugs here, there are several standards for these video adapter cables. There's a standard for camcorders, there's a standard that Apple uses for their devices, there's a standard that the Raspberry Pi uses, there's standards for other things, MP3 players. And in this case, this is a cable that I think is the standard for camcorders, which just has the ground connection on the wrong ring here. So yeah, I'm basically just going to have to buy another cable at some point. This was the cheapest one I could find. It doesn't really state the pinout on the website. I was sure this was working and I spent several hours trying to figure out the settings in BMC64 to make this work, while it was this cable all along. I just looked up the pinouts and measured it with my multimeter, and it's the wrong pinout. The ground is on the wrong ring. So yeah, I think the easiest way to at least get some kind of picture is to just clip these cables and just solder, just reverse ground and signal pins on each of these. Yeah. Okay, I reversed the polarity of all of these, and I'm going to put some electrical tape over these and some heat shrink tubing to have it a bit more secure. But in theory, this should already work. So I have my little Pi connected through the Composite Out that hopefully works now to the upscaler that I have set up here, which has an analog input to display it on this monitor. And hopefully there's going to be something. Yay! We have a PAL signal. And that actually looks like a lot like what you would see hooking up a C64 here. And there's some horrible lag introduced by the upscaler, actually. and some horrible interference because of the lack of shielding in the cable. Yeah. But basically it works. Yeah, we have an analog output signal now. It's not very good. I need a better cable at the very least. And yeah, it's not perfect, but it works. Finally. And we should be able to switch this to NTSC composite, and it should still output a picture. But in NTSC, and my upscaler should see that probably. NTSC, there we are, yay. The machine is actually running at the speed of the video output, so that's true to the original, if you will. The C64s are timed by the video output. I'm afraid my Sony monitor is not hooked up correctly, so I can't show you on the monitor. And of course, if you are younger than 30 or something, you are going to hear the CRT whine when I turn that on, so I'm not going to do that. I'm going to show you my TV later that I use in my retro gaming corner. So, in order to use a real DE9 joystick, we are going to wire up our joystick pins on our little connector to the GPIO pins on the Raspberry Pi. And we're going to use some of these DuPont cables here. We need 1, 2, 3, 4, 5, 6. So we need 3 cables. These are the female connectors. Just going to cut them in half, I think, because we only need very short wires, and I'm going to solder directly to the D9 connector. You can use pin headers on this, which probably makes things a bit easier, so you can just stick these on there and the other end to the GPIO pins, but I'm just going to solder to the connector here. And you can, of course, hook up a real keyboard in the same way, also with the pins on the GPIO header. And you can also use a user port, but not all at the same time. I think there's not enough pins for that. But we can have menu buttons on the GPIO pins as well. I don't need that because I'm going to have a keyboard connected. There we go. That's this end. And then we need to put it in the case somehow and wire it up to the GPIO pins. I think I'm going to have to take this apart here. So yeah, this just comes off. We can basically just cut this out here, I think, and fit this. It probably would be a reasonable idea to get the Pi out of the way as well. So I'm just going to take the Pi out for now. And then we're going to modify the case a bit. Okay. And I hope it still closes up after that. But it doesn't look half bad so far. Let's see if it still closes. Hey. Okay. Not too bad. So we are going to have to make some connections here that I'm going to have to look up the pin out for again. 6, 8, 10, 12, 6, 8, 10, 12. That's this one. Okay, so this is Gianna's Sisters. Let's see if my joystick works. Nope, not at all. That didn't do much. Possibly I did something horribly wrong. Okay, I think I got it. I wired this up wrong. I took the pin numbers as the GPIO numbers, but there's actually separate GPIO pin numbers. So the pin numbers on the connector are not the pin numbers for the GPIO pins. So we're going to have to wire this up again with the proper pins. And then it should work, hopefully. That's GPIO pin 17, and that's pin 11. 1, 3, 5, 7, 9, 11. Yeah, this makes more sense from a physical point of view here. It's all a bit closer together as well. So yeah, GPIO bank 1 we have wired up now. In theory, let's see. We don't have the joystick working. What's going on? Why doesn't the joystick work? Oh, we need to set up GPIO. Let's see. Yay, we have a joystick. And it works. Okay, so we have to activate the GPIO functionality here. So far, so good. That worked out well with some detours. We have the joystick working. That was the main thing. And also we have the emulator working over Composite Out at this point. Nice. So I made some more adjustments. You can adjust a lot in the emulator. I turned off scaling interpolation and now I have a much cleaner picture, but you can also customize that so you have an even better picture. And you can use different color palettes. You can switch through these. And I found that this Pepto looked the closest to what I'm used to from real C64s on this particular screen. But yeah, your mileage may vary, of course. And you can adjust the colors. You can even center the picture differently and stretch it differently in case your CRT doesn't work well with the modes here. Shouldn't be necessary for HDMI out, but yeah. And you have to, yeah, this is the one I missed, the configuration for the GPIO port. And you can, of course, if you use real keyboards hooked up to the GPIO, you have other options here, keyboard and joystick. But I'm using the navigation and joystick because I only have a joystick and a USB keyboard connected here. So I'm going to save these settings. And that shall be my settings from here on out. For now, I'm probably going to play with this a bit more. Yeah, but I can play games. And you can, of course, if you only have one joystick port physically connected here, you can switch that to the other port just as you would in Vice, because this is Vice. So you can have one joystick and just switch ports in case your game needs a joystick hooked up to the other joystick port. And we should be able to configure the joystick inputs so that there could be a USB input device, a gamepad hooked up for the second player. That is also an option. Or the second player can play with the keyboard keys. So that's pretty nice, pretty versatile. And of course you could hook up another joystick port to the GPIO pins. Maybe I'm going to do that at some point. But for now this is my living room machine here. And I think it turned out relatively nicely. You can put a lot of USB stuff in here, of course. Yeah, joystick port. And that's just a Pi in there. I just need a better cable. And of course you could, maybe I'm going to do that at some point, just put some real RCA sockets in here somewhere and hook them up to the pins on this TRRS socket here from the underside of the board. But you might as well just get a proper adapter cable, unlike me. Yeah, one of the best features actually, of course, is you can just turn this off without damaging anything. And you can just turn it on again and it should be there in 4 seconds. There we go. Approximately the boot up time of a real C64. Okay, here's my little retro gaming corner built around a 1980 Philips color TV that only has RF input. So I'm using a VCR, featured in one of my videos as well, a trash-picked VCR to convert the RGB inputs from my consoles that I have hooked up here to an RF signal, and that's displayed on the TV. This is actually my childhood TV, the first color TV my parents owned, and it still works without any major flaws. I have cleaned it a couple of times, but other than that, it's still in its original 1980 state. I hooked up the Raspberry Pi with the shoddy cable, so we're not going to have sound, and we're going to see how it works. So, okay, TV is running, let's turn on the Pi. And there we are. That's our Commodore 64, or our BMC64. And it does look quite similar to what a Commodore 64, a real one, would look on here. Of course, you can make some adjustments here. We can center the screen. I already did that. It's a bit off on this TV, but your mileage may vary. You can stretch it, the picture and things like that, according to what your screen needs. But this looks pretty amazing. Of course, you can change the palette to match what you would expect. So yeah, works really well. And almost feels like a real C64. Without the sound at this point, because I don't have a proper cable, as I've pointed out repeatedly. I'm sorry about that. The picture quality is not the best, of course, because it is composite that's converted to RF, and yeah, the cable is shite. But it feels a lot like a real C64. Super snappy. You can probably see that the scrolling is super smooth. It's not the best recording here, but yeah. This just completely and utterly works very, very well. And I don't feel any lag here. It feels like a real C64. Of course, there is a minor amount of lag, but I don't perceive it. And the picture looks absolutely great. It's going to get a bit better even if the TV is turned on for a longer time, because the capacitors are a bit worn out, but more on that in another video, I guess. Yeah, just wanted to show you that this actually works on a real CRT in my little setup where it's going to live. Sorry about the mirroring on the screen, but yeah, this just works. As expected, after some wrong turns that I took. And I also figured out the reason for my cable, my adapter cable, not working for sound. It is because I have one of these in this last row here. These are basically the variants of the cable that are available. The top row here is the one that we need for the Raspberry Pi, and I have the MP3 player variety, it seems. So ground is where the video pin should be, so reversing video and ground, changing these made the video signal actually available, but reversing the right audio and the left audio pins didn't do anything because we had the video signal as ground on those pins. So basically we have a completely useless signal on both of these now. Yeah, video works with this cable. It's really difficult to mod it for audio, so I recommend you get a proper cable. Even the camcorder cables work with the Raspberry Pis. You just have to use another RCA plug for video. That's the right audio plug. So you need the red plug for video, and yeah, the yellow plug is going to be the right audio. The white one is the left audio. That's actually the same as with the Raspberry Pi out. I have a new one on order and I'm going to use that in the future and hopefully get sound output. Yeah, I think that's it for today. Very happy with my little BMC64, which remains a bit of a work in progress because, as I said repeatedly, I need the proper cable for hooking it up to my setup. And I'm also going to put the ROMs for the other systems that this can emulate on there. So I have a VIC-20 and a C128 and a PET and a C16, or +4 rather, in my living room as well, that feel kind of like the real thing in a very small form factor. Love this. Thanks so much for your time. Hope you enjoyed this. Hope it inspires you to try BMC64 yourselves. Even though it is an older project, it still rocks. As usual, special shout out to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are in the video description and on my website. Thank you very much for your support. Without you, this channel would not be existing. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye!